This is the 10-1 video. This video is not going to focus on adding and subtracting polynomials, but it's going to give you the background and all the vocabulary that you're going to need for this entire chapter. Now, you're going to need to grab your notebook. You're going to need to take notes and jot everything down. And you're going to need to know that some of this you already do know already, but most of it's going to be new, and it's going to be a lot. So my advice to you is to jot everything down. All right, as promised, there's a lot of vocab. So the first term you need to know is standard form. Okay, this means the terms are placed in descending order. Okay, descending means going down. So when you look at these terms, 5x to the 5th power, 3x to the 4th, negative 7x to the 3rd, and 9x squared. These are in standard form because the exponents go down in descending order. So 5, 4, 3, 2. So that's what standard form is. Now another vocabulary term is the leading coefficient. So the leading coefficient when your polynomial is in standard form is the first number, the first coefficient that you would see. Again, that is only when your polynomial is in standard form. Okay, the degree of the term is the exponent of the variable. So the degree of this term right here is 5 because that's what the exponent is. The degree of this term is 4 because that's what the exponent is. The degree of this term is 3 and the degree of that term is 2. So the degree of the term is the exponent of the variable. If you have a term that looks like this, 5x squared y to the 5th, you would add the two exponent values up. So in this case, your exponent would be, or I'm sorry, your degree would be 7 because you would add the 2 and the 5 to get 7. Okay, next, the degree of the polynomial. Okay, it's the highest exponent value of the polynomial. So if I go back to this example here, the degree of the polynomial is going to be 5 because that's the highest exponent value. Before we flip to some more vocabulary, make sure you take a moment to jot all of these terms and examples down. As promised, there is a lot of vocabulary in this section. So grab your notebook, copy down this table. You're going to want a column for polynomial, degree of the polynomial, classifying by degree, and classify by the number of terms. All right, so let's start with the first example, 5. All right, so for 5, the degree of the polynomial is 0 because there is no x value. So if I added an x value, that would be x to the power of 0. That's why the polynomial has a degree of 0 because there is no variable. It's a constant because this will constantly be 5. The value of that will never change because there is no variable. And this is a monomial because there is only one term. So mono means 1. All right, here we have another polynomial, negative 17x. This has a degree of 1 because x has an exponent of 1. We say that this is linear because if we graphed it, it would graph in a straight line, and because the degree of the polynomial is 1. This is also a monomial because there is only one term. So negative 17x is one term. Okay, our next example, 15x plus 5. So 15x plus 5, the degree of that polynomial is 1 because the biggest exponent value that I have is 1. So if I can go ahead and add it there. This is linear. Again, if I were to graph it, it would graph in a straight line. But this is a binomial because there's two terms. So one of my terms is 15x and my other term is 5. So terms are what are separated by an addition or subtraction sign. The next term is this one, 2x squared plus 4x minus 6. This has a polynomial degree of 2 because my biggest exponent is 2. This is a quadratic because any equation that has a squared term, that's its biggest term, is a quadratic. Chapter 9, we graph those. Those graph into parabolas. And this is a trinomial because there's 3 terms. got 1, 2, and 3 terms there. So again, terms are what are separated by addition and subtraction signs. Okay, in my next example, I've got a expression that is 4x cubed plus 7x. So here's my expression. The biggest degree is 3, so the degree of the polynomial is 3. Anything that has the biggest degree of, or the biggest exponent of 3 is called a cubic. We haven't graphed these yet, but we will practice those in class. And this is a binomial because there are 2 terms, 4x cubed and 7x, making that a binomial because there are 2 terms. All right, the last thing that you have to know and understand for Chapter 10 in our semester exam is this example. All right, so I've got 18x to the 4th minus 5x squared plus 7x squared plus 2x minus 1. Okay, so in this example, the biggest term I have is 4, so the degree of the polynomial is 4. Anything with the degree of 4 is called a quartic. Again, we haven't graphed this either, just like we haven't graphed a cubic. So we will practice graphing those in class. And anything after a trinomial, anything that's bigger than that, we just classify as a polynomial. So when you're classifying by terms, you'll need to remember monomial is 1 term, binomial is 2 terms, trinomial is 3, and then anything after that, we just call it a polynomial. All right, so from this chart, what you need to know is that anything that has a degree of 1 is a constant. Anything that has a degree of, that was a degree of 0. Anything with a degree of 0 is a constant. Anything that has a degree of 1 is linear. Anything that has a degree of 2 is a quadratic. Anything that has a degree of 3 is a cubic. And anything that has a degree of 4 is a quartic. All right, and then when you're classifying by the number of terms, you look at how many terms there are. So again, if there's only 1 term, it's a monomial. 2 terms, it's a binomial. 3 terms, it's a trinomial. And anything with 4 or more is a polynomial. So one more time and one more reminder, make sure you copy down this chart and you understand how to calculate the degree of a polynomial. You need to know how to classify something by degree. So when you're classifying it by degree, you're looking at the degree of the polynomial. And then you need to classify it by the number of terms. So the number of terms, again, are going to be the number of terms in your polynomial. That's how you'll classify it.